Yeah, flip-flops. Yeah! All right, so far we've talked about circuits, but we haven't talked about how we store values inside our circuits. The computer has to store memory somehow, so we need to be able to come up with a structure in order to store it. The first one we're going to talk about is a latch, and then we're going to go on to a flip-flop. We're going to do a flip-flop. It may not make much sense, and then once we do our final processor, it'll make perfect sense why we always want to use a flip-flop instead of a latch. Oh, this is going to be so funny talking about flip-flops during an election year. Whew. All right. So we've talked about sequential circuits. So data you have your inputs, flows through a circuit, happens in parallel, outputs come in. But in reality, it's really a register loop that keeps running, so we need to come up with a way to store values. Right now, we've talked about our combinational circuits, in which case we have inputs, outputs, and that's all there is. This corresponds to our mathematical function where every single input has one single unique output, and so far that's worked out very well. But instead, we want to have this type of system where you have inputs. Your input comes from two things. One input, maybe your keyboard, and your other input is the current state of the machine. What application is loaded? Oh, it's this application, so I need to do this. So the memory, where program's running, and your input, your keyboard, then go into your combinational circuit, and that produces an output as well as any changes that need to happen to your memory state. So now you have two sections of inputs coming in, the physical input that we talk about and the memory state input. This is probably where things get confusing because you have states running around, and that always makes things hard. Since the same inputs can yield different outputs depending on what the memory state is. So even if you click K on your keyboard, K in one program, it means something different in another. That depends on your memory state. So what is memory? It should hold a value. You should be able to read that value and change that value. So you read the value and then you change it, and it shall always produce the same output. We'll start with the simplest case, a 1-bit bistable memory. It should be able to hold a single bit, 0, 1, the two possible states. You should be able to read it and you should be able to change it. Since it's only 1 bit, we'll have two choices. We can set the bit to 1 or reset/clear it to 0. In other words, you call set to change its value to 1. You call clear or reset to change its value to 0. All right. We don't care about this. We care about that. Here's a great circuit. What is that? Well played, sir. What is that circuit? Go. Oh, I was waiting for that. Yes. We'll just keep this going. All right. What's that?
Do you want us to explain it? Is that what you're looking for?
Yeah. What's going on here?
So, initially it doesn't have any value, but once you apply something, the output of one is going to go to the input of the other. So it kind of like.
Where'd the eraser go?
Those are ORs.
No, those are NORs.
Oh yeah, sorry. Yeah, those are NORs.
That is not an eraser. That's a box of chalk. Gabriel. It's Gabriel's chalk. Oh, here. All right. What are the inputs?
And then actually, I was going to say you actually get an input from, well, it's output. The output.
Yeah, so we only have two other wires called Q and Q naught.
Okay.
All right, so what are the possible combinations of inputs? There's two of them, so that means there's 4 in total. What are they going to be? 0, 0, 0, 1, 1, 0, 1, 1. Oh boy.
Alrighty.
We're going to skip the first one And the
Yeah.
last one, let's do the two middle ones right now. Person online, I drew the truth table, and we're going to do a reset of 0 and set of 1. So if reset is 0, and that goes into a NOR, that doesn't mean anything. If set is 1, the OR of 1 is always 1, which means that the output of the NOR with an S input is going to be 0. Because the S, because 1 or whatever, we don't care what, it's always going to be 0. Nodding that equals 1. Everyone see that? So that NOR has to be a 0 right now. Okay, great. So now we have the two inputs for the R, right? We have a 0 and a 0. 0 or 0 is 0. Nodding that is. So Q is 1. And let's just confirm we're okay by taking the 1 from here, moving it down here. 1 or 1 is 1. Nodding that 0. Hey, look. It set it to 1. Beautiful. Let's do the other thing. Oh, wait. Actually, any questions on that? Because that can be confusing. We doing great? All right. How about reset, reset of 1, set of 0? Well, let's do the top part first. The OR of 1 and whatever is, come on, loud and proud.
It's gonna be 1.
1, nodding that is 0. So Q hopefully is 0.
Yeah.
Now we have the two inputs for the bottom one, 0 and 0, which means the output is 0 or 0 is 0. Nodding that is 1. All right, great. Beautiful. Let's see. Let's go up to 0, 0. Huh. This is where things get interesting. I'm going to try and make your life a little easy. Let's start with Q starting off at 1 and Q starting off at 0. This is weird. You're not supposed to do this in a truth table, but this is a feedback circuit, so you kind of have to cheat. So if Q is 1, that goes down, we got an input for the bottom one. If Q is 1, that goes down to the 1 or S, which is 0, is 1. Nodding that is 0. So this would make a, so he would be 1 and this guy would be 0. Great. Now, is this going to work? I should have done it this way. I don't know why I put an extra line there. Let me make it a little clearer for y'all. So it's 1, so Q naught's a 0. Let's make sure we're still okay. Q naught is 0, going back up to R. 0 and R is 1. I mean 0 or 0 is 0, nodding that as 1, which is what the Q is. All right, we're doing great. Well, what if Q was 0 at this point? Well, 0 goes down to the S. That's not very helpful, but hopefully the Q naught's a 1. And if the Q naught's a 1, and the Q naught happens to be a 1, it goes up here, 1 or whatever, we don't care. It's going to be 1, nodding that is 0, which is what Q is. That's great. And then Q coming down, going over to this OR is 0, or hey, look, S is 0. So 0 or 0 is 0, nodding that is 1, which is the circuit. So what is 0, 0 doing? If your current values are 1 and 0 and you hold 0, 0, what are your next values? They're the same.
So it's just holding the memory.
Right. So this is holding the memory. This is how this circuit holds your value. Once you set or reset it, you hold the value by having R and S be 0. That'll hold the previous value until you change R and S. So 0, 0 is how you hold the value, aka don't change what's being stored there. Keep the same value. Because we just went through it that if we're at either of these two states, it retains that state at the end of the circuit, so the circuit does not change. All right? All right. Hope you all ready for some sadness. Okay. So we got a 1 for Q down here. By the way, online student, we're evaluating if R and S are 1 and 1, and if Q starts off at 1 and Q naught starts off at 0. So we have Q being 1 going in here. 1 or we don't care is 1. Perfect. Nodding that is 0. We'll send that up here. So 0 or 1 is 1. Nodding that is 0. Oh, wait a minute. But Q was supposed to be 1. I'm going to do that again because sadness just occurred. We're assuming that Q starts off at 1 and Q naught starts off at 0. All right? So 1, this Q, 1, goes down here to the OR. 1 or whatever, we don't care, is 1. Nodding that is 0. Good, because that's what Q naught was. 0 comes up to here. 0 or 1, R is 1, so that makes it a 1. Nodding it as a 0. Uh-oh. Q was supposed to be 1. Now you have something pushing on it that's supposed to be at a 0. What value is Q going to be? X. Because you have 1, which is previous, and then 0. Or actually, you know what? Hold on. You're correct. So 1 can't happen. Let's go to 0 instead. What happens if it's 0? Online student, we're now going to evaluate if the initial position was Q is 0 and Q naught is 1. So 0 going down here, 0 and 1, because S is 1, is 1, nodding that 0. And, oh, we've already messed up, because Q naught's supposed to be 1, which would then force it to change. This circuit is only going to cause sadness when you have R and S be 1. So I'm just going to do this. Nothing good is going to happen when R and S are 1. When you implement this circuit and you put in, if you ever put in R and S both as 1, you're going to get some weird outputs. Hopefully you'll get X's. You may get some numbers that make no sense. You may get Q being 1 and Q not being 1. It's going to be wrong. All right, we got to pause now because I didn't break the chalk. And talk